All right, so welcome back to our second and final episode of the Workload Identity series. In our previous episode, we discussed the origins of the Pod Identity Project, what it solved, but also some of the limitations that drove us to this newly released Workload Identity Project. If you haven't seen that episode, there'll be a link in the description to it. And so with that, let's go ahead and get back into talk about workload identity. So on to this exciting stuff. We're now going to show off the new workload identity with a demo and get into some of the configurations and features. So with that, Ernest, tell us about this new kind of what we're calling V2 project of workload identity.
All right, yeah. Thanks, Phil, for the introduction again. So workload identity is the next generation of the pod identity projects, and is, in my opinion, a much cleaner solution. It relies on a native built-in Kubernetes features called surface account token projections. And this features allowed users to project a signed surface account token to their workload's volume. And we're also relying on Azure Active Directory's new features called federated identity credentials. And I'll talk about it in a bit. And compared to the AAD pod identity solutions, we don't have to rely on IMDS to fetch the access token. Instead, we're directly querying AAD's endpoints with the surface account token in exchange for a access token. In addition, workload identity supports Windows out of the box, and it gets rid of all the CRD's requirement from pod identity. So yeah, let's dive into it. Workload identity only contains one main component, which is our mutating emission webhook. The first step of using a webhook is to create and annotate a Kubernetes surface account, which your workload will use. And there's a special annotations you can use in your surface account, which allows our mutating webhook to know which pods to mutate. And I'll talk about what kind of mutations we're doing to the pods. So once you set up your surface account, you will want to set up a federated identity credentials, which tells a particular AAD applications to trust on tokens that are generated from this particular Kubernetes clusters. And you can think of surface account as the Azure identity from the AAD pod identity projects, and the federated identity credentials as the Azure identity binding, where it binds the surface account with your workload. So once you finish setting up your surface account and federated identity credentials, you can now deploy the pods that uses the surface accounts. So the mutating webhook will pick up the emission requests and mutate your mutate your workload by injecting several environment variables, as well as projecting the surface account token to the workload's volume. Once it is mutated, your workload will start running. So there's no 40-second delay for the identity assignment, which is great because your workload can just start and grab a token right away. With all the environment variables and projected surface account token injected, you can leverage our Azure Identity SDK or even our Microsoft authentication library to request an access token. What it does under the hood for the SDK is that it'll automatically read the environment variables that we injected to the workload, as well as reading the surface account token. It'll use these properties to exchange for an AAD access token. And during the exchange, AAD leverages OpenID Connects or OIDC to discover the cluster's public signing keys and verify the authenticity of the surface account token before returning an AAD access tokens. And with that being said, I'll give it to Anish once again for a short demo.
Yeah, looking forward to this. I know in this, so first episode, you went through pod identity, A lot of moving pieces here, so I think we could expect a little, or much cleaner experience. So I'm excited for you to show this off.
Yeah. Thank you, Ernest, for the great introduction for the project, and then also talking about how we've overcome several of the limitations that we had in the pod identity project. So we have been working on Azure AD Workload Identity for a while now, and are really excited to have this finally available for our users to try out. This is based on the Workload Identity Federation, which is currently in preview from Azure AD. So let's take a look at it in action. Let's see a demo. So again, I have a 3-node AKS Kubernetes cluster here, which is running Kubernetes 121. And for the purpose of this demo, I've already enabled the OIDC issuer in this cluster. So the OIDC issuer feature is currently in public preview on AKS. So it's as simple as just adding a flag to your cluster create command or updating an existing cluster. So when you create a new cluster or update an existing cluster with enable OIDC issuer, an issuer URL will be set up and configured for your cluster. So let's see what my cluster issuer URL looks like. So when I do AKS show, there is OIDC issuer profile.issuer URL, using which you can see what the URL for your particular cluster is. So this URL is where the discovery document, the OIDC discovery document, and then the JSON web key set paths exist. So let's take a quick look on what those look like. So when I do a curl, the OpenID configuration, so this is the discovery document, and we can see this is the issuer URL, and then this is my key set URI. And then let's take a look at the public signing keys that are used for my particular cluster. So if you can see here, this follows the same spec from Kubernetes and also for what is required for OIDC. This gets set up, and all you have to do is update your existing cluster or create a new cluster with it. Now that we've looked at it, the next thing that we want to do is enable the mutating admission webhook, which simplifies config for the deployment. So for the purpose of this demo, I've already deployed the webhook in Azure Workload Identity System namespace in the cluster. It's as simple as just running a Helm command, and it will set up everything in a particular namespace. So let's look at the resources that's running in that particular namespace. So when I do get all in that namespace, we can see that there are 2 pods running. So it's a deployment, and it has 2 replicas. And then we also have a service which is in front of this particular deployment. So this service is configured for the webhook in the mutating webhook configuration. And then, as Ernest talked about it, all the identity configuration that you need to provide is done by annotating just service accounts. So as a user, all you would have to do is annotate the service account with client ID and then maybe tenant ID if you are using an application from a different tenant outside of your Kubernetes cluster. And then we also provide a couple of other knobs in terms of how soon you want the token to expire and some of those, right? So when the pod is created, the workload identity mutating webhook will use this annotated service account to know what environment variables need to be injected in this pod. And these environment variables can automatically be picked up from your SDK. So if you're using the Azure Identity SDK and if you use the default credentials, it will automatically pick up these environment variables, and then it will exchange a service account token for a valid AAD token. But if you're using MSAL, then you can consume these environment variables without having to manually add these to your application. So for the demo, first thing let's do is create a namespace where we're going to be doing all of this. Then the next thing we want to do is just create a service account with the required annotations and then also the labels that's required. So here, what I'm doing is I'm creating a service account in this namespace. And then if you look at it in the annotations, I have a client ID, which is the client ID of my application. And then the labels here is just used to tell the mutating webhook that this service account needs to be used for workload identity. So go do your magic. So you can notice that I already have a client ID here, right? Which means I have pre-created my application. So the next step is we need to configure the Azure AD application to trust tokens issued to this particular service account. So it's the service account namespace, name, and then the issuer tuple. There are several ways that you can add this federated identity credential. So one is Cloud Shell, which is what we have in our documentation, or there is also a way to add it in the portal. And then the portal experience is pretty new. So that's what we're going to be trying in this demo. So when we go to the portal, in this application, so I have an application called WI00. And then as you can see, this application client ID is what I use to annotate my service account. The key part is certificates and secrets. So one thing you can see in this application is I have no client secrets at all because I don't need that. So what we're going to do is add a federated credential to trust the service account issuer that we just created. So here, when I do add credential, you can see that this can be enabled with GitHub Actions, or now we have another section for Kubernetes accessing Azure resources. So the service account issuer URL. So we already know what the issuer URL is for my cluster. So I'm going to add that here. Also, to make sure that you don't run into any errors, whatever issuer URL you get from your AKS output, you want to paste exactly that. So if there is a slash at the end, you would want to add that as well. And then in terms of the namespace, the namespace that I'm using for my service account is called WI-demo. And then the service account name that I'm using is WI-demo SA. So this was a service account that I just created. So you can see that as I provided just the name and the namespace for my federated credential, it was automatically able to generate the subject identifier. So it follows the Kubernetes spec, and then this is the format that the subject identifier would look like for my service account token. So let's give this a name and then add the credential. So now we have set up a federated identity credential for this application. So we've basically bound the cluster issuer and the service account and namespace with this particular application. So now that the service account and the credential are created, what we're going to do next is obviously create a pod in this namespace, which is going to be referencing the service account. So I'm going to run a simple kubectl run command. And then as you can see, we are again using the Azure CLI container. And then here in the service account, we are saying use WI-demo SA. And then here I have a node selector, but again, this is workload identity and it works on Linux and Windows. So you don't have to constrain yourself to just Linux. So now we're running this pod, and as we talked about it, we have the mutating webhook. So it would have injected a couple of environment variables that I can consume. So let's look at the environment variables it added. So as you can see, it added the Azure tenant ID, which is default to the cluster tenant ID. But if you are using an application in a different tenant ID, you could just overwrite it with an annotation. And then it also added that federated token file. So this is the file path to where your service account projected volume token is. And then the Azure authority host is which AAD endpoint you want to talk to. And then we have the Azure client ID, which was annotated in the service account. So the mutating webhook just made it a lot easier, where it injected all of these things that you need rather than you having to go and modify every pod spec to include this information. So the next thing is we can see all these environment variables are there. Now let's just try to get an access token from the container for the Azure AD application. So within the pod, I'm running AZ login again. By now we should be familiar with this command. But if you look at it, I have everything as an environment variable. I am not using any hard-coded value because the mutating webhook has made it simpler. So when I run AZ login, service principal with Azure client ID, tenant ID, and I'm passing in the federated token, which is the service account token. And you can see here that the login was successful. Let's just quickly validate if we can get an access token. And if we run this, ta-da, so you can see how easily we were able to get an access token based on workload identity federation.
And you gotta You gotta love those mutating webhooks. And I must say, I mean, much cleaner solution than the original pod identity solution. And that's one of the things to note is understanding some of the limitations of the pod identity project kind of factored into us really not taking that project all the way to a GA state. As Anish showed off this workload identity, it's more in line with industry standards and much more durable solution for long term. So if you had any questions about, hey, why isn't pod identity GA? Hopefully you can go look at episode 1 and see kind of how pod identity is done and then compare it to workload identity and just see how much this is a much cleaner experience. So that was awesome, cool. Let's now talk about like the roadmap for workload identity. We just recently open sourced the repo up on January 11th of this year, 2022. And I'll just do a quick share out to that repo there, so everyone can see that. And so again, you can go out now and start testing this and give us some feedback on your experience. Ernest, Anish, any additional roadmap items for discussion that you may want to tell the community here?
Yeah. Let's see. So workload identity right now only supports federated identity credentials with AAD applications, but not managed identity. But we're currently working with the AAD team to support that because we know that almost 99% of the users who are using pod identity are using managed identity, and not having managed identity support for workload identity must be frustrating for them. And we're trying to get a private preview as well as a public preview for managed identity as soon as possible. So please stay tuned. Once managed identity is supported, we will start working on the seamless transitions from AAD pod identity to workload identity. I'm sure that most of the pod identity users will want to try out workload identity once managed identity is supported. And we already have a solutions for a migrations path where folks who are using pod identity can also use workload identity without changing any of their application code. So please stay tuned. Additionally, we're also planning to improve the developer productivity of the projects. Specifically, the Azure CLI team, as well as the Portal team, are all working on improving the experience around creating and editing federated identity credentials. And it looks like Anish has already demoed, the Azure Portal already has a preview on adding and deleting federated identity credentials. So that's great. And last but not least, the AKS team is currently working on natively integrating this open source projects with AKS clusters. So yeah, lots of exciting stuff happening, and please follow our GitHub repo for any news, and feel free to open any issues or pull requests against the repo.
That's it. Hopefully you tuned in, you like what you saw, and you're pretty excited about the future of the Workload Identity Project. I want to thank everyone so much for taking the time out and hanging out with us in this new Azure Upstream channel. And let us know, again, in the comments how you like this quick series, and if there's any other projects that you'd like for us to discuss. Again, as mentioned, please check out the repo. That can be reached at github.com/Azure/Azure-workload identity. And again, all the links that we talked about will be in the video's description. Anish, Ernest, it's been real and it's been a pleasure. Thank you so much for hanging out and walking us all through this really cool project. I know there's been a lot of blood, sweat, and tears involved in the way the sausage is being made. So again, thank you for your endless efforts in getting this project out there to the community.
Yeah, I want to say thank you for hosting this. I think this is really great for us to also reach out to users, get great feedback, and then also see how we can take the project going forward.
Yeah, thanks.
All right. Okay, well, with that, we'll end it. Thanks again, everyone, and be on the lookout for other projects that we're going to be discussing here on the newly Azure Upstream channel. So thank you.